Okay, the first question is, what is impedance? You'll remember in your technician study, you had something called resistance. And resistance is opposition to the flow of electricity in a DC circuit. Okay, impedance is a similar thing, opposition to the flow of current, but it's in an AC circuit now, which makes it much more complex than a DC circuit, because very different components in an AC circuit will oppose the flow in different ways. And this is where electrical engineers earn their money, is in alternating current circuits. But impedance is the opposition to the flow of current in an AC circuit. The word resistance means approximately the same thing in the English language, doesn't it, as impedance? You resist something or you impede it. You do something to reduce its ability to move or to affect things or so on. So even the just ordinary English words are approximately the same in meaning. And in this case, we use impedance to talk about the opposition to flow of current in an AC circuit. What is reactance? Reactance is one part of impedance, and it's caused by either capacitance or inductance in the circuit. It's opposition to the flow of alternating current caused by capacitance or inductance. Okay, it's called reactance. So the capacitor or the inductor is reacting to the alternating current in a certain way, and this is frequency dependent, as we'll see as we go through here. Which of the following causes opposition to the flow of alternating current in an inductor? This is reactance. In this case, it's inductive reactance. Looks like the same question. Which of the following causes opposition to the flow of alternating current in a capacitor? Again, it's reactance. In this case, it is capacitive reactance. How does an inductor react to AC? Okay, as the amplitude of the AC increases, the reactance increases. So as the frequency goes up, did I say amplitude? Slap me, somebody. Amplitude has nothing to do with reactance. It's all based on frequency. As the frequency of the applied AC increases, the reactance increases. So in an inductor, as the frequency goes up, it's more difficult to get the current to flow. As the frequency of the applied AC increases, the reactance increases. How does a capacitor react? Just the opposite way. As the frequency of the applied AC increases, the reactance decreases. So AC flows more easily through a capacitor if its frequency is higher. What happens when the impedance of an electrical load is equal to the internal impedance of its power source? Okay, when that is true, when the impedance of the load is equal to the impedance of the source delivers maximum power to the load. Okay, and we talk about this. One place we talk about this especially is matching transmitters and transmission lines to antennas, because we want to get all of the power that we can into the antenna. And so to do that, we have to match the impedances of the transmitter, the transmission line, and the antenna, so that the maximum power can be delivered to the load. Why is impedance matching important? So the source can deliver maximum power to the load. What unit is used to measure reactance? It's the same unit, by name at least, that we use to measure resistance. It's the ohm. What unit is used to measure impedance? Again, it's the ohm. Which of the following describes one method of impedance matching between two AC circuits? The answer is to insert an inductive capacitive network, an LC network, between the two circuits. This will improve the matching. Changing the power doesn't do anything to change the match. Okay? So putting a matching network in will do it. What's one reason to use an impedance matching transformer? It's to maximize the transfer of power by matching the impedances. Which of the following devices can be used for impedance matching at radio frequencies? A transformer, a pi network, a length of transmission line? All of these choices are correct. A pi network is what you commonly find in an antenna tuner. You can have an impedance matching transformer of various kinds. Or for radio frequency, you can actually use a specific length of transmission line depending on the frequency to do an impedance match. So all of these choices are correct.